Okay, welcome to week 8. You have survived. You've made it to the end. You have persevered, and you have done well. I'm proud of each and every one of you. So we're going to conclude this course talking about systems development lifecycle and project management. So in this unit, the first half we'll be talking about the SDLC, or the Systems Development Lifecycle, and we'll be talking about software development methodologies and Agile software development, Waterfall, and service-oriented architectures. Then we'll conclude with project management, specifically using project management to deliver successful projects, the elements of project planning, outsourcing, and primary project planning diagrams. All right, so section 9.1. The SDLC, or the Systems Development Lifecycle. Organizations must learn how to build and implement disruptive technologies. Well, there we go again. Something from week 3, cycling back around, and we're hearing it again in week 8, chapter 9. Software that is built correctly can support agile organizations and can transform as the organization and its business transforms. Software that effectively meets employee needs will help an organization become more productive and enhance decision making. That feeds back to the previous chapters talking about data analysis and decision making. We've had at least 2 or 3 chapters on that alone. So again, all of this ties back in together as you would expect. As an organization's reliance on software grows, so do the business-related consequences of software success and failure, including your revenue going up and down, your brand reputation being improved or diminished, liabilities, and then your productivity. So all of that comes into play as this technology, which is often disruptive to some nature, is impacting your organization. So let's look ahead. This is what the SDLC looks like, and we will be looking at these in a little bit more detail as we move forward. So I'm not going to go through any definitions at this point beyond pointing out that at the top you have planning. Everything starts here, right here in the planning phase. Then you transition to analysis. Then you transition to design. Then you transition to development, then testing, then implementations, and then maintenance. Once you hit maintenance mode, everything starts over from the beginning again, because in maintenance mode you find something to modify, you find something to make a change to, and when you do, you have to start back off in planning. Never, ever, ever try to take a shortcut and go from planning to design, thinking that you can assume that the analysis is things are just understood. As sure as you do that, your project is going to hit some major snag along the way. So let's go through and look at this in a little bit more detail. The planning phase establishes a high-level plan of the intended project and determines the project goals. So in other words, in the planning phase, we're saying, what is it that we want to achieve? What do we want to accomplish in this? What is the expected outcome from this? All of that gets defined in the planning phase, and you always want to be as thorough as you can at a high level view. I know those two terms kind of contradict each other, but it's crucial to play those together. The analysis phase involves analyzing end-user business requirements and refining the project goals into defined functions and operations of the intended systems. I still love their definitions. They seem so wordy. The analysis phase is basically where you say, okay, we know what we want to accomplish. We think we can accomplish this, but we don't know what it's going to look like. And so in the analysis phase, you start involving the individuals that can play a part in that. This chapter is more so than the other chapters in the text, takes a harder slant towards software and software development than the others do. Every other chapter in all the other weeks we've had, we can take the viewpoints of, okay, we have these concepts, and it could apply to IT, it could apply to business, it could apply to my life in general, but the exception here is with this chapter 9 and talking about the SDLC phase. So I said that to set the stage for this, talk a little bit more about the analysis phase. You have the ideas of what you want to accomplish with your IT system or with your software, but you don't know the impacts that what you're wanting to change may have on the other areas of operations. And so you want to try to bring as many of those individuals and diversify this panel for the analysis phase as possible, so everyone can have these conversations about your brilliant idea that's going to help revolutionize the company. So the analysis phase, that's where you start looking at the details and the nuts and bolts of how is this going to actually impact other parts of the system. The design phase establishes descriptions of the desired features and operations of the system, including screen layouts, business rules, process diagrams, pseudocode, and other documentation. If not pseudocode, you would definitely do flowcharting or some type of graphical visualization of the steps you need to take to make this happen. The design phase says, okay, I recognize that we have the general goal that was identified in planning. I understand that everyone has had a say in how this should play out, the analysis phase. So what do we want it to actually look like? And that's where you're drawing all of this out. So this way, when you're done, you can hand off the documentation out of the design phase. You turn around to your developer and say, okay, here's the project, here's how much time that we've estimated it's going to take to do. We need it by this date. So you need to get it added to your production list or your task list to do it. And then it rolls into step 4, the development phase, which involves taking all of the detailed design documents created in step 3 and transforming it into an actual product or solution. Excuse me. So the developer takes it and starts making the concepts into something real. Once they have done that, the developer will then go through a series of testing. Now, in 2 or 3 upcoming slides, we go into a lot of detail on like it's either 4 or 6 testing phases. And so I'm not going to go into those here other than to say the testing phase is where they play out, is this thing working? Are there any errors with it? Is there anything that we need to go back and readdress? Is it going to play happy with everything else on the system? Or is it going to shut down order entry? Or is it going to cause the website to crash and customers can't place orders? Testing phase helps answer all of those questions of insecurity that management typically has, and justifiably so. Once it's past all the testing phase, then it comes down to how are we going to push this modification into the regular system for everyone to be able to use, into the production system for everyone to be able to use. This involves placing the system into production so users can begin to perform actual business operations with it. And again, even with implementations, in a couple of slides, there's like several types of implementations we'll talk about and approaches to that. All right, so I said that there were 6 types of testing. Here's those 6 types of testing. And let me turn real quick in my notes to where this 6 types of testing are. Here we have I'm sorry for the delay. I know that that gets awkward in recording, and it's even more awkward when you and I are not sitting face to face, so you can see my point of confusion in looking at the notes versus the slide. Okay, sorry about that, and sorry about the little ramble. Alpha testing assesses if the entire system meets the design requirements of the users. So in alpha testing, are the basic expectations and requirements met? If so, check. We go to development testing and we ensure that it's bug-free, that when you add 1 plus 1, you're going to actually get 2. That type of testing happens in development. Integration testing verifies that separate systems can work together, passing data back and forth correctly. So in previous weeks and chapters, we've talked extensively about systems thinking and how MIS plays the little part in the middle of connecting all of these different departments and maybe their independent systems together so that they can all share data and communicate with each other, making the organization more efficient and effective. Well, in integration testing, integration says, okay, we're going to have to now throw this piece of modification into that middle mix. How is it going to interact with the HR system? How is it going to interact with the shipping and receiving? How is it going to interact with order entry? And it wants to make sure that it does not disrupt or cause a negative impact in any other area on the system. And that leads us to system testing, verifies that the unit or pieces of code function correctly when integrated. Integration and systems testing kind of go hand in hand, accomplish the same thing. UAT, or user acceptance testing, determines if the system satisfies the user and business requirements. So it says, okay, everything is playing nice and happy at this point. Everything looks good. Now, are we sure that we're meeting what the user is wanting? And is what the user wanting, here's the caveat to this, is what the user is wanting, is it really meeting the business requirements that they were thinking it was going to meet initially? Now, it sounds like that question should have been answered in steps 1 and 2 of the SDLC, in the planning and analysis phase. But you really can't answer that fully, to a full extent, until you see how it's going to be used and how it's going to actually interact with the users and the rest of the system. So you have to actually see it in action to fully answer that question. And then last, unit testing. It tests individual units or pieces of code for a system. And again, that just kind of is a Cliff Notes version of the first 5 types of testing up above. When it passes testing, it rolls into implementation. There's 4 types of implementation that can happen. There's parallel. It uses both a legacy system and a new system until all users verify that the new system functions correctly. There's the plunge. That's taking the leap off the cliff. Well, I'm not saying that there's no regard, but you're understanding that you're taking the leap, you're shutting off one system, flipping the other on. Good or bad, you've got to go with it. Pilot implementation. This is where it's kind of like parallel, but instead of running them both at the same time, what you're doing is you've designated certain employees to actually start using in its full entirety the new system, while the other employees are still using the legacy system. Both are real live, hitting production, processing orders, sending out bills, data. And the difference between parallel and implementation is that in parallel, the new system doesn't really send out orders. It really doesn't send out bills. It really doesn't send out anything. It's generating that, and they compare the old versus the new to make sure everything is lining up. But with Pilot, a small segment is processing on legacy, a small segment is processing on the new system, and both are going out and impacting the customers. Phased implementation is simply taking an implementations approach by saying, okay, this is the order that we need to implement the departments within our organization, and it's prioritized based on whatever criteria, and then you go to implement the first department and get them live and operating on the system, and they're successfully using it with no or very minimal issues, and then you get green lighted to go to the next department. It's more like a departmental approach to that. Now, in one of my previous jobs working with a software firm, what all of this looked like for us and bringing this into a real life perspective. We were a software firm that specialized in the flooring industry. And naturally, we lived this process. And as I was talking about all this, that's what I was envisioning, what I would go through on the average day there. So planning for us would happen when a client would call in and say, hey, your software is working great, but it would make our life a lot more easy and a lot better off and a lot more efficient and a lot more effective if it could do ABC instead of XYZ. So we would take that request. We would log into our management system that we used for keeping track of customer interactions. And eventually it would go to a business analyst for them to start looking at and doing their legwork. They would say, they would either say one of two things. They would either say, well, our system really does that. If you were to change this flag and this flag and this setting, it will do what you're wanting. Or they would go, well, no, you can't do that because that's not really the industry standard for doing that particular operation. Or the last response would be, yes, this looks like a great idea. Let me send it up to the powers that be to see if this is an enhancement that we're going to pay for and roll out ourselves, or if this is an enhancement that we need to give you a quote on for you to pay for, which typically is what happened. There were some things that we paid for, but for the most part, the clients paid for these modifications. Once the analysis was done, then it would go to the design phase, and there that business analyst would sit down with some of the, with one or two veteran developers who'd been there since the start of the business, and they would sit down they would also invite at least one other business analyst. They would invite the client service manager and the manager of the developers. And they would present this stuff, and it would have to be approved by everyone in that little meeting. By that point, that business analyst had created the concept drawings of the screen arts. the laid out details of the requirements, and all of that documentation that we mentioned here in the design phase, they would go to that meeting with all of that already in hand for approval. Then it would be approved to be put on the production schedule and to be assigned to a developer. Then the developer would go through testing. Now, we had 3 different systems. We had a development system, we had a testing system, and we had a production system. And all 3 of those were 3 separate systems running our software. Now, we would do all the development on the development system, and when we would go through the testing and get the testing approved and make sure that everything checks off from our standpoint, we would then do a process called promote it to Q&A for quality assurance, and it would copy all of our work onto the testing system. Then the Q&A, the quality assurance person, he would go through his checklist of testing. Once he was through, then he would green light it for us to copy and place on the requesting clients box for them to use it. And so it would stay there for 30 days for them to use to see if there was any impact. You remember we just went over this here. We would see if there was any impact on, well, I thought it was there. Here, integration testing. We would see if there was any impact that it would have on any other parts of the system testing, before we would put it in production for the rest of our client base to be installed on their computers or on their systems. They weren't computers, they were systems. And so from there, it was then implemented in production and part of that. And then it would roll through maintenance where a couple of years down the road or whatever, we'd get another call maybe on that little piece of software and for another modification to be done. So it was a never-ending cycle, that we lived through and that made us go through day-to-day operations. Maybe in your organizations, I don't know if any of you work full-time or what your statuses are, but have those, get to know someone in the IT department, have those conversations, or one of the business analysts, and see what that looks like, what the SDLC life cycle looks like for your organization. Lastly, we've talked about this, so I won't say too much on it. Maintenance phase involves performing changes, corrections, and additions and upgrades to ensure it is continually meeting business goals. Okay, there's several different methodologies when it comes to software development. You have Waterfall, Agile, Rapid Application Development, or RAD, Extreme Programming, Rational Unified Process, or RUP, and then Scrum. A waterfall methodology simply lays out a sequence of phases. And what's produced in one phase becomes the input for the next phase. The planning, the output from here is the idea. Well, the idea becomes the input for the analysis. They're going to conduct the analysis. That output becomes the input for design. That turns into all of that documentation, which is the output. The documentation becomes what the developers start with. The developers turn it into a solution. The solution being the output becomes the input for testing, and I think you get the idea of that, so I will save you going through all of that. But notice how it lays out the phases and it lays out a time to give the project manager an idea of where a project should begin and end. Now, you would never really lay out the Waterfall methodology by a planning, analysis, design, with all of that, like specifically like this, but you get the idea. The second one, Agile, it introduces an iterative development. Basically, you have the one big goal that you want to accomplish. And when you have that big goal, you say, okay, in Agile, you say, okay, let's break that up into much smaller baby steps and smaller tasks. And you keep going back and revisiting that task over and over and over and over again until, or iterations, until you do enough of the small task to complete it, to complete that project. Agile methodology aims for customer satisfaction through early and continuous delivery of useful software components developed by an iterative process using the bare minimum requirements. So if they were wanting to have a customer management system, an iteration might be we create an order entry screen. Bare minimum order entry screen, what do you need to get an order created? Well, then once that's created, then we go back and we'll add a little bit more to it, which might be to modify an order. And then once we get that done, we'll go back and visit it again and add another task, such as maybe print off order reports. And so you keep building on it until you eventually get a fully functioning product. RAD emphasizes extensive user involvement in the rapid and evolutionary construction of working prototypes. A prototype is a small-scale representation of a working model of the user's requirements or a proposed design. Now, when I was working at that software firm, when I was working at that software firm, around 2010, they said we need to look at modernizing it a little bit. And by modernizing it, they really wanted to create more user-friendly interfaces and screens for the users and make it more like websites and make it more like web pages that they were keying and using, which ended up looking very sharp. But before they just started rolling out, okay, this is how we're doing it, they created an R&D team consisting of 2 or 3 of our veteran developers, and they sat behind closed doors and they developed a small sample of a piece of it on the system. You know, they recreated a part of the system to demonstrate what it would look like, and that was a prototype. It wasn't an actual functioning system, but it was just like a model of what it would look like. It's cheaper, it's inexpensive, and it gives a visual of what to expect so you can tweak and change it as you are creating the requirements for that. Extreme programming, or XP methodology, breaks a project into tiny phases, and developers cannot continue on the next phase until the first phase is complete. So again, it kind of looks like Waterfall, as it looks like it's a trickle effect, but I can't go from here to here until this phase is fully complete. RUP provides a framework for breaking down the development of software into 4 gates. Now, I've not really have known anyone to use RUP. I'm not saying that it's antiquated or anything like that. I've just not seen it in action. Gate 1 is inception, Gate 2 is elaboration, Gate 3 is construction, and Gate 4 is transition. Now, a SCRUM methodology uses small teams to produce small pieces of deliverable software using sprints or 30-day intervals, one of the two, to achieve an appointed goal. Each day ends or begins with a stand-up meeting to monitor and control the development effort. And this is what, when we started, when the prototype was approved and specifications were created on that revamping and re-engineering the software package, they paid for the project management certification for one of our employees, and he transitioned into that role full time. And Scrum is the adopted methodology that they use. I don't know how they went about deciding that's the one that we're using, but that's what they did. And so what that looked like for us, it was at the beginning of each day, they had one wall that was a big whiteboard that had every project that people were working on. And it had the beginning and ending date and things like that. It kind of looked, well, we'll show a Gantt chart in the second section, but basically it was kind of laid out like a Gantt chart. But we would stand around in a big circle, and everyone would have to answer these three simple questions. What did you do yesterday? What are you working on today? When will it be complete? And in answering those questions, if you had hiccups or snags, or if you were having barriers to getting your job done and meeting your deadline, that could come up at that point. And if other conversations needed to happen, well, then they would have breakaways at the end of that Scrum session to be able to address those. So, if nothing else, Scrum opens up communication between all involved parties at the same point in time. Communication is the biggest key to success in project management, and that's what the Scrum helps to create. Service-oriented architecture, or SOA, is a business-driven enterprise architecture that supports integrating a business as linked, repeatable activities, tasks, or services. And here you can see the visualization of that. Okay, that concludes section 9.1. Make sure you have on the radar screen your final exam. That's coming up here this week in place of a quiz. So make sure that you're reviewing and studying. It is not cumulative. It's going to be over chapters 5, 6, 8, and 9, those last 4 weeks that we covered. And you should do fine as long as you've been reading and contributing to the discussions in the course. Again, make sure you're doing your discussion questions. Make sure that you are participating and getting your work in, especially any work this week, so I can conclude your grades in a timely manner.